All right, let's talk a little bit about transformations. All right, so here's the definition. Function f from a plane P to another plane P is called a transformation if f is 1 to 1. There's a fancier word for 1 to 1. You can also say injective. All right, which means that if f of p is equal to f of q, then p must be equal to q. Or another way to say it is if you have p and q are different, f of p and f of q must be different. All right. And the second condition is it has to be onto, which means that no matter what point you pick from the codomain, you can always find the point in the domain, which is the plane P, such that f of P is equal to f of P prime, right? So it means that every point in the codomain will be hit by this function, right? And a fancier word for onto would be surjective. And if you combine the two, you can also say it's a bijective. So which means that it's injective and surjective at the same time. All right. All right. Then if this transformation preserves the collinearity, which means that a line is going to get mapped to another line, then it is called the linear transformation. Okay, because it preserves lines. All right. And since it's bijective, you probably know that if it's injective 1-to-1 onto, then we know that there exists an inverse function. And so f inverse exists. All right. So here's a concrete example from xy plane to xy plane. So function f is going from R2 to R2. And here's the definition, right? So the x-coordinate of the new point is defined as 2x plus y plus 1. And the new y-coordinate is x plus y minus 2, right? Let's do a few simple problems. All right, let's say original point is 3, 1. And can you find its image? So I'm going to call it f prime, a prime. Right, a prime is really the same thing as f of a, right, which is f of 3, 1, right? So all you have to do is find let's find the x prime. So x prime is going to be right 2 times right x value is 3, so we put 3 there, plus y is 1. Plus 1. So 6 plus 1, so this is going to be 8. And y prime is going to be, right, x is 3, and y is 1, and minus 2. Right, so it's going to be 4 minus 2, so that's 4. Right, so therefore, point is going to be 8, 4. Right? So that's the A prime. All right, let's do part B. All right, so if you have a point at 2, 2, we want to find a P such that the f of P is equal to 2, 2. All right, so in this case, this is x prime and a y prime. All right, so all we have to do is solve this equation. All right, so you have x prime is 2, which is equal to 2x plus y plus 1. Right, y prime is 2 is equal to x plus y minus 2. Right? Then we can just do, so let's try to get rid of y. So an easy way to do that is actually just go through subtraction. Right, 2 minus 2 is 0. and 2x minus x is x. All right, y minus y is 0, and 1 minus negative 2, so it's a 1 plus 2, so it's going to be plus 3. All right, so we know that by subtracting 3, we know that x is going to be equal to negative 3. All right. Once you found the negative 3 x value, we can use either equation. I think I like the bottom one better, so I'm going to plug negative 3 in here. All right, so that way I'm going to go up here. All right, so we're going to get, let's see, 2 is equal to, all right, x is negative 3 plus y minus 2. All right, so we have, let's see, there's a negative 5 there, so I'm going to 5 to both sides. So it's a 7 is equal to, that's going to go away, so it's going to be y. All right, so therefore, P is going to be, x coordinate is negative 3, and a y coordinate is 7. Right? So that's those are the coordinates of the point P. All right, so we know that it's a bijective function has an inverse. So let's try to find the formula for this inverse. All right, so we have this system of equation. I'm going to solve this equation for x and a y. All right, so first I'm going to write it down. X prime is equal to 2x plus y plus 1. And then we have a y prime is equal to x plus y minus 2. Right? As before, we can just simply go through subtraction, which will give us x prime minus y prime is equal to x plus 3. Right? So we can simply subtract 3 so that the 3 is on the other side. So it becomes x prime minus y prime minus 3 is equal to x. All right, so we got that. And then we want to solve for y. All right, so I'm going to actually do the similar thing since we already have x right here. I'm going to just plug this guy right here. All right, see what happens. All right, so that's going to get us. So y prime is already there. All right, I'm going to replace this x by x prime minus y prime minus 3. And then we have a plus y and a minus 2. All right. Then we can just move all these guys except for y over to the other side. All right. So we're going to get, let's see what we're going to get. All right. So x prime over the other side becomes negative x prime. Right. All right, negative y prime over to the other side becomes positive y prime, but we have another positive y prime, so it's going to be 2y prime. And here's a negative 3 and negative 2, so it's negative 5 over to the other side becomes positive 5. And y is all by itself. All right, now we already know the answer, right? So f inverse is going to have a formula. All right, x is going to be equal to x prime minus y prime minus 3. And y is going to be equal to negative x prime plus 2y prime plus 5. All right, so that is the formula for the inverse transformation. All right, that's it. I hope that this was clear.